Hi everybody. In this video we're going to learn how to multiply and divide monomials. Though I'm a 7th grade teacher and most of my videos focus on the Indiana standards for 7th grade, my advanced class does work with the 8th grade standards as well. And this is in fact over some of those 8th grade standards. First of all, you need to know that a monomial is an expression with only one term. So it's a math problem. Usually, when you think monomial, you think of an algebraic expression or a variable expression. But this one only has one term, so you don't have different parts that are separated by addition or subtraction. What you need to know for this, there's two main exponent rules that we're going to focus on. The first one is for multiplying. And it basically just says when you're multiplying and they have the same base, you keep that base and you add the exponents. Just as a little review, the base is the big number. It's what you're multiplying. And the little number is the exponent. It's how many times you're multiplying it. Even though a lot of these are going to have variables instead of numbers, it still works the same way. There in blue, I have written out kind of my little shortcut reminder for what this rule really is so that it doesn't sound quite as confusing. Think about if you wrote all those out. So instead of x to the third, if you actually wrote x times x times x, do that with each monomial and then count how many times you've written it out total. That's how you decide what your new exponent is going to be. So let me show you some examples. This first example, we have two monomials that we're multiplying. I'm going to focus on each one of those variables individually. Let's look at the x's. In the first monomial, I have 3 of them. So you could write x, x, x. In the second monomial, there's 1 of them. So altogether, you have 4 that you're multiplying. So that's going to become x to the 4th. And look, that shortcut or the rule told me you keep the base, we kept the x, and we added the exponents. 3, and if you don't see 1, it was a 1. 3 plus 1 gave me 4. For the y's, the one on the left, I have y and y. On the right, y, 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 and y. So altogether, that would be y to the 6th. Again, we kept the base, we kept the y. In the first monomial, there were 2, and in the second one, there were 4. So altogether, there were 6. Finally, on the z's, you can write them out, or we've got 1 on the left, we've got 5 on the right, so altogether, we would have z to the 6th. Oh no, it's doing that thing where it doesn't want to write, which seems to be tradition in every video I make. All right, number 2. When your monomials have coefficients, you're going to multiply those numbers just like you normally would. So I'm going to take 3 times 4 and write down that's a 12. On my A's, on the left I have 2, on the right I have 1. So altogether I have A to the 3rd. On my B's, I've got 7 on the left, I've got 3 on the right. So altogether that would be B to the 10th. I don't know why this thing is such a pain. I think it's actually my stylus, but I've never found another stylus that I like quite as well as the one that just came with my Acer Chromebook. If anybody has any suggestions, leave a comment in the post. I would be happy to hear them. I've tried other stylus brands, but I just can't find any that I like that write quite as well. But I think this one's just kind of wearing out. Okay, for number 3. On the coefficients, I have a 2 here. I don't have anything there. Just like with normal variables, if you don't see a number written, there's really a 1. 1 times 2 is 2. On my m's, I have m to the 6th and then m or m to the 1st. So altogether, that would be m to the 7th. N to the 2nd, and look, there's no n in the other one, so I just need to leave it n to the 2nd. And then same deal with the p's. There's p to the 3rd in the right monomial, but none in the left, so I'm just going to include that p to the 3rd. Oh goodness, it's really not behaving today. There we go. Okay, so second exponent rule is for dividing. The real rule talks about when you divide and the bases match, you keep the base and you subtract the exponents. I don't actually do the subtraction, especially when we get to negative exponents, which you'll see in another video. I think it's so much easier to ask yourself, do you have more on top or more on bottom, and then how many more? Otherwise, when you subtract, sometimes you get into these negatives and then you still have to end up rewriting it with a positive anyway. If you do this more on top or more on bottom, then you can kind of skip that whole middle step. So here's what I do. I rewrite my fraction bar. And if I end up not to need it later, that's fine. We can just rewrite our answer without it. I look at each individual part. So on my x's, I have 4 on top and I have 2 on bottom. So I ask myself, do I have more on top or bottom? And then how many more? I have 2 more x's on top. On the y's, y to the 9th, and then on the bottom, that's really y to the 1st. Think of it this way. If I canceled out the pairs, 1 on top and 1 on bottom, I would have 8 extras on top that don't cancel. And then the z's, I don't have more on top or bottom. They cancel each other out. It's like saying 5 over 5 is really 1. Z over z is really 1. And when you take something times 1, you don't even see a change. So we don't even need to write those z's. They cancel. So I'm going to rewrite my answer as x to the 2nd, y to the 8th. The ones you see in this section, you're not going to end up needing anything on the bottom of the fraction. I'm doing that kind of a lead in to when I get to negative exponents because that's the same practice I use and it works really well to just go ahead and set up your fraction like that. Let me talk for a minute a little bit more about what I meant by the canceling. So let's look at these x's. I had x to the 4th on top and I had x to the 2nd on bottom. If I actually wrote those out, that would be x, 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 x on top, and x, x on bottom. When I cancel them out, I want to take one from the top and one from the bottom as long as they match. So take that pair out, take that pair out. I'm left with 2 on top, just like I had right here, the 2 on top that didn't end up canceling. It was a lovely arrow, wasn't it? Okay, let's look at number 2. Now, these have coefficients, but it's also just like a fraction, 10 over 2 or 10 divided by 2. So that's really a 5 on top and a 1 on the bottom. And if we end up, hint, hint, we'll end up not needing the bottom, then we'll just rewrite our answer. A to the 5th on top, A to the 3rd on bottom. I have 2 more A's on top. So I'm going to put A to the 2nd there beside that 5. On my B's, I have 6 on top and 3 on bottom. So I have 3 extras on top. So B to the 3rd on top. On the C's, I have C to the 2nd on top. That's really C to the 1st on the bottom. So I have 1 extra on top. Anytime you have something to the exponent of 1, you don't have to write it at all. So instead of writing C to the 1st, I'm just going to write C. That 1 on the bottom of the fraction isn't really doing anything for me. So I'm just going to rewrite this as 5a squared b to the 3rd c. Now the actual rule, if you look back, it was about subtracting. So before I do this last one, let me show you these again with subtraction. For example, on the first one, instead of just canceling the 4 and the 2 to see I have 2 extras on top, I could do x to the 4 minus 2, y to the 9 minus 1, and then z to the 1 minus 1. I'm left with x to the 2nd, y to the 8th, z to the 0. Anything to the 0 is really just a 1, so that would disappear. And I would just be left with that answer, exactly like we just did. On the second one, I would still need to do 10 over 2 and get 5. But then for the variables, I would have had a to the 5 minus 3, b to the 6 minus 3, and c to the 2 minus 1. I'm still going to get the a to the 2nd, b to the 3rd, and c. The only reason, like I said before, that I don't do that is because when we get into negative exponents, doing it with the do you have more on top or more on bottom ends up saving you a little extra time and brain strain there. Last one, number 3, 12 over 4 is really just a 3. The m's cancel. I don't have more on top or bottom. They just cancel each other out. Now the ends, I went ahead and wanted to show you one where you end up with something on the bottom. And again, you're going to see a lot more of that in the negative exponents video. That comes just a little bit later in this unit for us. But I have into the one on top, into the second on bottom. So I have an extra n on the bottom. And then the p's, I have 5 on top and 3 on bottom. So that's 2 extras on top. So I'm going to leave that as 3p squared over n. If you're working on multiplying and dividing monomials, hopefully that helped you out some. Thanks for watching the whole video. Feel free to subscribe. My YouTube channel is Math with Luger. I focus on 7th and 8th grade math standards. And that is my school email there if you need to contact me with any questions. Thank you so much. Until next time. Bye.